Humanity has set its sights on deep space. Engineers are currently designing the rockets, habitats, and logistics required to build permanent settlements on the Moon, and eventually the red dust of Mars. But getting there requires surviving the journey. The vacuum of space is a radiation-soaked void, and the absolute absence of gravity immediately begins dismantling the human body. To solve this biological problem, we had to build a testing ground closer to home. Orbiting 250 miles above Earth, the International Space Station serves as a specialized zero-gravity laboratory. This schematic outlines the station's interconnected modules, highlighting how a human subject operates inside. Every system here is designed to figure out exactly what it takes to keep a person alive in an environment actively trying to kill them. We cannot safely launch crews to another planet until we master biological survival in low Earth orbit. Inside the station, the environment is incredibly confined. Astronauts exist in a perpetual state of freefall, meaning every mundane human action, from moving to breathing, requires mechanical adaptation. Take something as simple as sleep. Without gravity to hold a person in a bed, an unconscious astronaut would drift through the cabin and collide with delicate equipment. To prevent this, crews strap themselves tightly into sleeping bags mounted directly to the walls. Mealtime introduces its own physics problems. Liquids and crumbs don't fall to the floor, they float, creating a severe hazard for the station's electrical panels and air filters. All food is specially packaged, and liquids are consumed entirely through sealed pouches. Waste management relies on similar strict engineering. Since gravity cannot pull waste down, the space toilet utilizes targeted vacuum suction to safely pull biological matter away from the body and contain it. This graph demonstrates the severe biological toll of weightlessness. Over a standard 6-month mission, an astronaut's bone density drops sharply, mimicking rapid-onset osteoporosis, while muscle mass wastes away from a complete lack of use. To combat this rapid decay, the crew is subjected to a rigorous medical regimen. They strap into specialized resistance treadmills and hydraulic weight machines for 2 hours every single day, forcing their bodies to maintain structural integrity. Surviving in this environment requires deliberate, continuous effort. Left alone, the human body simply cannot sustain itself in orbit without heavy, engineered intervention. Once basic biology is stabilized, the crew shifts to their primary objective, executing physical labor and complex science in a vacuum. The lack of gravity allows researchers to conduct experiments that are physically impossible on Earth. They synthesize pure protein crystals for disease research and forge new metal alloys without the heavy defects caused by terrestrial weight. The ultimate test of human capability happens outside the hull. During extravehicular activities, or spacewalks, crews leave the pressurized safety of the station to conduct repairs and install hardware in the open void. Operating out there is exhausting. The spacesuit acts like a stiff balloon pressurized against the vacuum. Every flex of a finger to turn a wrench requires immense effort, forcing the astronaut to fight the suit itself while navigating extreme temperature swings. This intense physical labor generates crucial operational data. Every bolt tightened on the station's truss teaches us exactly how to construct complex machinery in a zero-gravity environment. By mastering inward survival, these crews are able to perform heavy construction outside, establishing the precise workflows we need to build infrastructure on other worlds. When the work stops, crews often float to the cupola module to gaze out at the curved, thin blue line of Earth's atmosphere resting against the absolute black of space. From this vantage point, the true value of the last 2 decades comes into focus. The continuous human presence in orbit operates as a relentless biometric data gathering mission. Every hour on a treadmill, every drop of water recycled, and every meal from a pouch provides the exact medical baselines required for a multi-year journey through deep space. We now have the hard data necessary to return to the lunar surface, this time with the capability to establish a sustained presence in the craters of the Moon, and it gives us the engineering blueprints required to fuel the heavy lift rockets that will carry human crews all the way to Mars. The International Space Station has laid the groundwork for humanity to expand outward. Our next great leap is already underway. Hit subscribe and join us as we follow the journey.